Hello there, and welcome to Brian Banks' review of number 2 of the 2008 free response questions. AP Calculus, of course. Oh, I remember back when I was a young lad taking this exam. I just want to tell you guys, relax. It's not terribly hard. I usually like to say if you do really well on it, it's 100, well, I wouldn't say 100, but it's 90% Miss Roshan's doing that you did well. And if you do really bad on it, it's 100% you're doing that you did really bad. So credit pretty much always flies her way. Great teacher, great class. Now, on to this problem. The question asks us for us to use the data in the table to estimate the rate at which the number of people waiting in line was changing at 5:30 p.m. Immediately, once I hear people waiting in line changing, once I hear changing, I think derivative. So, and of course we have to show our work and include units of measure, just like in any other free response question. So I'm thinking derivative. So it's basically just asking for the derivative at 5:30 or 5.5. Now if we look at our table, we're only given the values t equals 0, 1, 3, 4, 7, 8, and 9. But we need t equals 5.5. So let's look at two values that could give us a good estimate of what f prime 5.5 would be, and that is 7 and 4. So just like you've been doing all year, you're going to do L of 7 minus L of 4 over 7 minus 4. You guys learned that probably the first few months of school and comes back. You just do it out and input the values as such, and you get 8. And don't forget your units, people per hour. Moving on to the next question. It wants us to use a trapezoidal sum with 3 subintervals to estimate the average number of people waiting in line, only during the first 4 hours that tickets were on sale. Okay, so they already tell us we have to use a trapezoidal sum. So that's pretty easy. We know our formula there is base 1 plus base 2 all over 2, and then times our height right there. So if we do that for our 4 values, which would be t equals 0, t equals 1, t equals 3, and t equals 4, just as you can see here, we will get our answer. But what you want to make sure you don't forget is that we have 4 values here, and they're looking for average. So we need to divide it by 4, otherwise known as multiplying by 1/4. And then if you just do simple arithmetic, plug in numbers, you'll get 155.25. And then of course your units, people. Moving on to our next problem. From 0 to 9, so basically, they only give us 0 to 9 hours, so throughout the table, what is the fewest number of times at which L prime of t must equal 0? And then give a reason for your answer. So,
how you doing, buddy?
Okay, Aaron. Interesting. So you guys probably learned the intermediate value theorem right here way back in the day, maybe a few months ago. So this is where it comes up again. So using the intermediate value theorem, we must first remember that it's a continuous and differentiable function, or at least it's continuous and differentiable on the interval 0 to 9, what they're giving us. And that's very important to note, because without being continuous and differentiable, there's no way you can even use the intermediate value theorem. But since we know it is, we can use the intermediate value theorem, and we use this instead of, the mean value theorem or something else, because we're dealing with values. You can't see what's over to the right, but we're dealing with values, not slopes. values. Okay, and so using that, you'll find 3 times pretty easily. The hard part of that question is not actually finding how many times L of t must equal 0, but figuring out what method to use. And again, that's the intermediate value theorem. And lastly, it asks for the rate at which tickets were sold from, again, 0 to 9. This one gives you the equation for the rate at which tickets were sold from 0 is less than or equal to t, which is less than or equal to 9. And so that is R of t equals 550t e to the negative t over 2. Tickets per hour. Again, units are important when you're dealing with free response questions. They'll take off points, and those are easy points to lose or gain. Based on the model, how many tickets were sold by 3 p.m. to the nearest whole number? Okay, sorry, I had to pause it for a second there. Some kids walking by. Anyway, they give us the rate at which tickets were sold, which is R of t equals 550t, again, e to the negative t over 2. So if we look at, what can we use to find out how many tickets were sold? The antiderivative. And actually, this is a great problem because on the AP that I just took, they ask a lot of conceptual questions, like, what does it mean, using units to take the derivative of something, or the antiderivative. So this is a good question to point out. So taking the antiderivative, we take it from 0 to 3, because they say t equals 3. And using our calculator, fn int and all of that, we'll get 972. And here, just asking for the nearest whole number, no units. So that's pretty much it. As you can see with a lot of these problems, and it's not just this question, but a lot of free response in general, it's more executing the problem is not very hard. It's just more figuring out what you have to do to execute it. And again, that's where Ms. Roshan holds her expertise. So just listen to her. Ignore pretty much everything else you hear, especially from Aaron. If Aaron made a video, Aaron Wagner that is, you should really just sort of pass over that one. If Ms. Roshan asks if you watched it, just kind of nod your head. And if she's really onto you, just tell her, Brian Banks, that it's okay not to watch that video. Because, he's a great kid, works really hard, but just doesn't quite grasp the concepts. He doesn't quite have it. So if you're watching his video, I think he did question 1 to this test. Just kind of, fly by. My number is 301-802-0575. So if you have any questions about Aaron's problem, I'm more than happy to help you with it, so you don't have to watch that video. He struggles. Good kid, but he struggles. Thanks again for watching.